I'm sitting here with, what was it called again? Expanding Remnant, yes. Uh, every once in a while I like to take a step back and try to gain some perspective over what I'm doing and what I find interesting. That means breaking with old habits and throwing away things from previous projects to start fresh with new ideas and new approaches and, most importantly, new circuits. The sound from this was actually conceived on my modular synthesizer, which meant analyzing and documenting that patch and transferring it to a breadboard before even prototyping it on a perf board to isolate the more delicate parts of the circuit. Here's actually the Instagram story I posted on the 22nd of March, which would later turn out to form the foundations of this piece. Anyway, this is Expanding Remnant and I'm gonna tell you all about it. As usual, you can find a showcase of the work in its completed state at the end of the video, and all the background music heard throughout is generated either by this or previous works. Thank you for your time. To truly break with my residual habits, I tried a few different things to change my approach to this project. I decided to forego what has been perhaps the staple of my artistic process, namely freeform electronics. Some years ago, my mindset was that using freeform electronics would lead to some sort of transparency between the circuitry and the audience, maybe as an attempt at further strengthening the perception of these machines as communicative entities. And I don't regret doing that, considering how complicated this project would turn out to become, but it's probably not something I will stick with in the future, as I ended up missing the intrinsic character this type of soldering brings to a piece. But in this project I wanted to explore if I could gain clarity while retaining some of that transparency by focusing more on the architectural layout of the bus wires without overshadowing the signal routing with loads of minute details. And speaking of architecture, my second attempt at distancing myself from my own past was to write a set of design rules, which obviously was promptly ignored once I started modeling. But it allowed me to analyze what I like and what I don't like about my previous works, and to distill and formalize that into tangible principles that can be used in future projects. While some of the resulting rules are somewhat baked into a regular design process by default, such as having a clear color strategy, for example, something like the 60-30-10 principle in cinematography, where you have two dominant colors and an accent color. The most salient of the rules I came up with was using layered and intersecting bus lines, which doesn't sound very important at all, but it was what stood out to me as the most enjoyable in my own works after having analyzed pictures. So, regardless of the absence of freeform electronics, this was probably one of the more difficult to assemble projects I've ever done, which I knew going into it, of course, as I have designed it myself and was aware of the possible pitfalls. But the inconvenience was compounded by my own mistakes, which I suspect was due to the length of the project. I like to work in concentrated bulks, and this stretched out over 3 months and was quite fragmented, and even though I had written everything down on checklists, I often forgot to consult them because I'm so used to working with all the necessary information already stored in my short-term memory. One of the first mistakes I made was oversizing the pocket for this acrylic pipe I had intended to use, so I ended up designing a 3D printed replacement instead. Actually, one of the rules I had set for myself this time was to minimize 3D printing, so we were off to a good start. While 3D printing is fine for custom parts where there are a few other options in terms of manufacturing from home, I don't think too highly of it as a craft, at least in isolation. I quite enjoy subtractive manufacturing methods purely from an aesthetic standpoint, as the part produced bears witness to having been worked on and refined. When it comes to CNC routing, setting up a job often takes longer than the job itself when you factor in workpiece holding, programming of tool paths, and of course manual tool changes. My CNC router is rather small, which, besides the obvious size limitation, multiplies the amount of refixturing I have to do for each part produced. So I do what I can in-house and outsource the larger pieces to local companies. I'm actually on the lookout for a better machine with a larger work area, so let me know if you have any recommendations. Strangely enough, one of the, household brand names of desktop CNC machines reached out the other day and offered me one, but I turned them down because the work area wasn't quite as big as I would have liked, and I'm a bit sad about that because it seemed like a nice machine. I already mentioned that this was one of the more challenging assemblies I've ever done, and the reason for that is that the piece consists of 5 different vertically stacked stages, maybe better described as floors. Instead of wires and removable connectors, these floors are connected directly together with stiff soldered bus wires. And without foreshadowing too much, that means that if something is wrong on the second floor, the 3 floors above must be desoldered and removed before I can investigate. And I knew this when I designed it and decided that it was fine, because I never make mistakes. What I'm working on here is the first, or rather the bottom floor, where the LEDs and the vacuum tube electronics are situated. As you can see, I'm about to test and confirm whether it works before I move on to the next floor. And before we move on, and you can see that everything is indeed working, I just wanted to bring to your attention that a personal victory has been won. I've intermittently mentioned my stance on 3D printing throughout this video, and I am excited to announce that I've finally gotten to use my printer for what I originally bought it for, namely jigs. Specialized jigs for keeping wires in place while soldering. The information I will try to convey next might be a bit convoluted and difficult to wrap one's head around, especially if you didn't immediately skip to the end or didn't watch the demonstration video I posted a few days ago. So far, I haven't even played a single second of audio generated by this piece, and that feels like a completely natural choice as it is reflective of my own experience making it. I had very little idea of how the audio would turn out when I started this project, except for that rudimentary synthesizer patch I showed you at the beginning of the video. But regardless whether you have heard the sound of this piece or not, I will try to explain how it works. In terms of analog circuitry, I don't really know what's going on, to be honest, at least not in technical terms. It might be some sort of abstract cross-modulation or some obscure derivative of frequency modulation, but as I said, it's basically a reverse-engineered synthesizer patch where I've done my best to replicate the same order of modulation with the same parameters. But let's start with the basic building blocks and take it from there. You have the aforementioned analog circuitry, which consists of 2 sawtooth oscillators, 3 voltage-controlled amplifiers, a low-pass filter, and a vacuum tube for overdrive. The digital circuitry comprises the microcontroller, digital-to-analog converters, and LEDs. And to keep things cordial between the analog and digital blocks, there is an intermediary stage that takes care of buffering and signal leveling between the two. So everything sounds quite normal so far, but if we take a closer look at the analog section, you will see that one of the oscillators is connected to the control voltage input of the second oscillator after going through a VCA, while also controlling the cutoff frequency of the filter through a second VCA. The output of the second oscillator is connected directly to the input of the filter, with the resulting signal going through a third VCA before ending up at the vacuum tube. So I think if it wasn't for the audio rate oscillator controlling the cutoff frequency of the filter, this would have been fairly traditional FM synthesis. But considering the high resonance of the filter, there is a second layer to it. Besides, the amount of modulation is determined by how open the VCAs are, so there is a constant change that is hard to keep track of. If I had to describe what the various parts of the signal chain are doing within the sound itself, I would say that the main noise, if I can call it that, comes from the filter and its resonance, while the faint beating or rhythmical element of the sound is a result of the two oscillators being very closely tuned to one another. The gnarliness is helped by the tube overdrive, but it's not as influential to the overall sound as one would think. There are a few digital auxiliary elements as well. Maybe the first that springs to mind is the reverb. Secondly, you have the constant and steady sinusoidal pulse sprinkled with occasional blurbs of Morse code on top, in addition to two sawtooth oscillators singing along on either side of the stereo soundscape. A less prominent element is a really low bass frequency that comes in during Morse code and underneath the actual analog signal. So, what did we learn from this? I certainly learned that I'm not impervious to mistakes, and that it's probably a good idea to accommodate more for that in the design phase. Let's actually summarize the mistakes while we're at it. The first one, which I alluded to in the relevant chapter, didn't have anything to do with the LEDs, but rather the vacuum tube circuit, where I had soldered the output capacitor to pin 9 instead of pin 8. Here you can actually see an example of what I later had to undo to rectify that mistake. It seemed like a big brain move at the time to design these vertical wires to be soldered through a hole in the floor of the sculpture, but frankly it was the only way to reach them, so I can't be too upset about that. The second mistake was somewhere in the filter. I can't quite remember what it was, but again, it meant yet another round with the desoldering iron. The final mistake was that I had sort of improvised the value of an op-amp resistor, which led to a weak output signal from the tube. I had to dismount the entire right side of the sculpture, desolder about 30 different joints, and insert a 200K trimmer at an accessible angle to make the signal usable before putting everything back in place again. There is one more thing, which is more of a native quirk of the Daisy Seed, which is the microcontroller I've been using for the last few years. It's this buzzing drone whose frequency can be calculated by dividing the sample rate by the block size. With good grounding, this can be negligible at the output, but every time I feel like I've finally nailed the grounding, it comes back to haunt me. It honestly feels like a lottery at this point. But I think the vacuum tube might have had a hand to play in this particular case. And I usually manage to figure things out by rerouting a few wires, but I wasn't quite in the mood for that after the overall calamitous final stages of this project, so I added a couple of notch filters in the code at 6 and 12 kilohertz and called it a day. In the end, I think I'm quite happy with how this turned out. I had been feeling a little bit trapped by the tonal and more traditional soundscapes employed in some of my previous works. So it was refreshing to do something slightly more abstract, perhaps even Lovecraftian, since I'm quite drawn to that kind of vague, obscure, or cosmic in general. But I did associate this sculpture with quite a lot of stress, actually, especially after everything that happened during the assembly. But it was nice to sit down with it afterwards, when everything was in order, to just sort of improvise and sculpt the sounds. A lot of it was sort of an afterthought, because I didn't have a finished sound when I built it like I normally do, so all the Morse code and bleeps and bloops and all that didn't exist, and the LEDs were sort of just there because I thought, well, I'm going to need LEDs, haven't I? So a lot of the stuff was programmed only when the piece was actually finished, but that was sort of nice to just, yeah, as I said, improvise or sculpt. So as you can see, I'm desperately trying to turn the machine on, but I had forgotten that I needed to make the external speakers. This is the first project I've done without any internal speakers. So there's 2 stereo speakers that are connected by banana plugs, and they are Dayton ND65-8 with matching passive radiators, so it's quite a deep and decent sound image you get from this setup. But I think that's it for today. The code and schematics are up on my Patreon page for those who are interested in a deeper dive. I'm not gonna push that too far because I haven't posted so much recently, but if you're still here, thank you so much for your time, and I hope to see you soon.